Hi everyone. I am Saniya. This cutie is cute little Yankee. And in this video, Yankee and I are going to show you how to get started with Cytoscape, a network visualization tool. So how can you use Cytoscape to make some initial figures of these graphs or networks, connecting these nodes together and their different relationships with each other. So oftentimes networks are called graphs as well. Not like the typical XY graph, but it's just like how these nodes, how these entities are related to each other. This is Cytoscape here, an open source, free software platform for visualizing complex networks and integrating those with any type of attribute data. So lots of problems can be solved. So it's open source bioinformatics software platform for visualizing molecular interactions and integrating with gene expression profiles, other state data. You can use it for any application. Cytoscape is pretty cool and it's free. Lots of networks that you can create. So we'll talk more about in other videos. I just wanted to show you how to get started. And what we're going to see now in this example is about SpongeBob's family. Okay, and we can see the relationships like married or child as well. And this is just SpongeBob's immediate family. So sadly not including Gary, even though pets like you can be great buddies and Swissers. So we're going to get started and visualize an example of SpongeBob's ancestry family, his parents and uncles and his grandparents and his cousins and so on. And we're going to see just how we can do that using Cytoscape, which is a free software that you can download and work with. So let's get started, Yang-Shi. Let's start to visualize these networks. And I really hope that you guys will find it useful, and please subscribe and share and do reach out with any and all questions. And I'll be creating some more content about network visualization using Cytoscape and other tools as well. So let's get started. Okay, so I was telling you about this network that we have here. So Yangshi, we have this network, and this network is of SpongeBob and SpongeBob's family. So we can see, it's my little star here. This is the logo married or child as well. And, with Grandpa SquarePants, who's married to Grandma SquarePants. And I love the episode when Grandma SquarePants tries to make SpongeBob lots of cookies, but he's very embarrassed because he gets bullied. How sad. Oh, Yangshi, you won't be embarrassed of me, would you? And so they're married here, so it kind of goes both ways. They both are married. And then Grandpa SquarePants and Grandma SquarePants had three sons, Sherm SquarePants, Old Blue SquarePants, and Harold SquarePants. And Harold married Margaret, and Margaret is SpongeBob's mom. So these two are married, and they're SpongeBob's parents here. Again, they're married, so it's green. And their child is SpongeBob. So in a way, it's kind of like these edges are kind of going this way and this way. That's how they're going. And Shim had two sons, Stanley, and Stanley can't do anything right, Yankee. He messed up things, and Mr. Krabs was excited because he thought that Stanley would be really good at helping out. Just looking like SpongeBob, but he's actually very clumsy. And then Todd SquarePants. So they're two are brothers, and these guys are all brothers here. And Old Blue SquarePants had Blackjack SquarePants. So this is the network that we want to show, and it can be anything. So here, each of these is like nodes, NODES, like nodes. And in the graph, they have these edges here. These are the edges in the graph. Edge, 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 like anything that is showing a relationship among these nodes here. So we can have all sorts of graphs, but I wanted to start out with Cytoscape in this simpler graph as well. I want to show you. Yes, Yankee, how we can show this structure. Okay, so let's see. So I encoded this network as follows. We can have the following relationships. The start node, we can have a start node here and a finish node. Okay, so you can call it whatever you want to call it. That's what you can call it. Start node to finish node and a relationship for now. So I would say grandpa and grandma, they are married. Grandpa to Sherm is father to child. Grandpa to Old Blue is father to child. Grandpa to Harold is father to child. Grandma to Sherm is mother to child. Grandma to Old Blue is mother to child. Grandma to Harold is mother to child. Harold to Margaret is married. Sherm to Stanley is father to child. Sherm to Todd is father to child. Old Blue to Blackjack is father to child. Harold to SpongeBob is father to child. And lastly, Margaret to SpongeBob is mother to child. So this is the edge list. I can have whatever I need. I just need this to be like a source node, like, it's coming from and going here. So if your graph goes in both directions, or if the nodes go in both directions, like in married, then it doesn't really matter which is first, what's the end. But when it's directed, like, father to child, its direction, it's an arrow. Bidirectional can mean just, arrows in both ways or no arrows at all. So this is how the edge list could look, for instance. You need to have a starting node and a finishing node. So this is a source node. It's often called the source node. And then this would be the target. So it always goes source to target. That's what it's called. So then I have constructed, Yankee, this edge list here. So this right here is a Cytoscape edge list where, I just copied and pasted it. We have a start node, our finish node, and our relationship here. And then I also kind of looked at all these different nodes that we have here, all of them. So you can just take them here, and then you can just, in a new one, we can just kind of look at all the unique nodes that they have. Data, and then remove duplicates. So we have around 10 unique nodes, Yankee, in this network. 10. So these are the 10 nodes. And now we're going to kind of see how can we describe this network using these 10 nodes as well. Like what are the properties of these 10 nodes? They can have anything, Yankee, any properties. So let's see what we will define for those nodes. So you then need to have, it will be helpful if you have, it'll be helpful if you have some node attributes. So then I have this other file where for each of those 10, I have the node name, node type, and generation. So I just defined some features for them. So grandma and Margaret, they're both female here. So I also said, okay, they're females. The rest are all males in the diagram. Then for the rest, I kind of said, okay, these two are the grandparents. Then these are parents, they have their children here. They're the second level, level 2. And then these are the third level. These are the children here. So if we look at this, we can see that as well, this hierarchy of parents, of grandparents, parents, and the children. So we have basically for this network representation, we can have an edge list and we have a node list. Yankee, this is the part we've been looking for. We're going to now load it into Cytoscape. Yay! So we're going to load up this network in Cytoscape, which will help us visualize something like this network here. So we need the edge list here, And it's helpful, especially to have the node types here. But if not, then you can still make the network, but you do need an edge list. So I'm going to open up Cytoscape. This is the application that we are looking at, and it's called Cytoscape. And it reminds me a lot like, Cyto, like, it's like one of these dark web kind of things, Yankee. I'm just going to show you now how we can come here to the Cytoscape demo, and we have the edge list and the nodes as well that we can use. So we're going to go here and we're going to load in, and again, the Cytoscape edge list. It looks like this: start node, finish node relationship. So we're going to load in this network here. So I'm going to go here and I'm going to click this network button here. And in Cytoscape demo, I'm going to click Cytoscape graph edge list. So now when I've clicked it, so I've clicked this button here, which looks like a network, these nodes connecting by these edges. So click on it. I need to have a start node, which is the source node, a start node that is the source node here. And then the end node, which can be the target. So it typically goes in these types of networks, it goes as source to target, source to target. So that's how it goes. So, and this will just be an edge attribute, basically. It's just going to be some edge attribute. We can also have source node attributes, target node, but it's going to be some edge attribute right now. And again, this is just one of many ways to do it. This is just a simpler introduction to Cytoscape, how to just get started. So there's so much more, but I'm just showing you one way to help you get started, Yankee. Okay. So then we have loaded in this network, and it looks a lot like this. We have the shared name as well, and we have these edges as well. We have these relationships. So then the other thing we can do is load in these node features to learn more. We have the edge table filled out, but the node table just takes these 10 nodes. But we need to also import those features. So we can go import table from file to help us load in the node features for each of these nodes. So I'm going to go to Cytoscape graph nodes. And the file that I'm looking at will be this one, node type and generation. We can add any of those features, but it's going to look at this as the key and map it to this. This could be node name, it could be anything. But when I load this in, it's going to see that, import to the network collection, or imported as node table columns here. So I have loaded this in here. So we have the names, the node type, and the generation. So this is a network here, but we are going to see how we can use this network, Yangshi, how we can visualize it. So we have those edges, we have these nodes, and how can we visualize it? So Yangshi, we're going to see how we can visualize the information. So I can go to network, I can look at the styles of the network as well. And under the style of the network, well, there's so many different types of styles. And I typically like to select, sometimes I like to select this style here. It has these information: Stanley, Sherm, Todd, Grandma, Grandpa, Old Blue, Blackjack, Harold, SpongeBob, Margaret. Would want to kind of color these nodes based on the generation. So what I want to do is I want to go here to fill color. Fill color is the color of the node. So if I change this color, it would change everything. If I were to change it, like, make them green, they'd all be green. That I don't want to do that though. So let me just kind of make it like a reddish color. I can make them all red. And what I can do is I can say, I want to map them based on the generation. So based on whether you are in the grandparents, parents, or children, I want to map it. And discrete mapping means that I'm going to have just a countable number of categories. It's not something numeric. If I'd done name, then you'd have seen that I can go here. Maybe if I want to make SpongeBob in yellow, I could just go here and say yellow, and then SpongeBob would be yellow. But I don't want to do by name, I want to do by generation. So discrete mapping will say, okay, these are the three categories. And pass-through mapping means that you need some kind of a value, you need some sort of a, like, it needs to be continuous. Maybe you have weights on your edges. Maybe, you know, you have some sort of an assignment to them. Or maybe the node is like, the node size could be the age or something. Maybe the more, the older they are, the darker the color, some kind of a gradient. But right now, I'm just going to do generation. So I'm going to do discrete mapping. So for the children, I'm going to, this red means that this is the default value. For the, if I can put the same here, or I can just say, okay, for the grandparents, I want the grandparents to be like a green, a nice green color. And then for the parents, I want the parents to be in yellow. So this is showing grandma, grandpa. These are the four, you know, like in the parents' generation, the second generation, and then the four that are in the children generation. Then I can also look at the height as well. And let's say that we're really interested, especially in SpongeBob. So I can just say, okay, node type discrete, and SpongeBob, maybe I can make the height of SpongeBob's node. The height, maybe instead of 40, which is the default, I can just make this like 60. Because SpongeBob is the big guy here, or something like that. And you see that the default is 40. If I don't specify it, then that's what the default is. Then what I can do is I can look at how typically what we observe. And you can see the little guy in the back. He's just cleaning himself. Aw, honey. Aw, aw, he's so cute. So what you can see is that typically what we have is that like this usually refers to like, and there's a lot of these pedigrees or so. This is usually for males, and circles are usually for females. And I know they also have they, you know, I'm an LGBTQ ally, so I know that this is not exhaustive, but let's just say for now we use this kind of thing here, where maybe we want to encode this relationship. So then what we can say is under the shape, I can say that the shape will be based on the node type. So node type then gives us female or male. Then I'll say, okay, female is going to still be the circle here for the node shape. So I can keep that there. And then for the male, I can just say that, you know, male is just going to be a rectangle. So everybody but Grandma and Margaret will have these squares. And just maybe just to bring it home, I can still also just keep this as an ellipse, you know. And if I did change this from an ellipse to a diamond, we could see that, no, even though that's a default, I overrode both of them. But I'm going to keep it as an ellipse. Okay. So then for the label font size, I can increase the size of the fonts. And this is also helpful, especially like, you know, if you're zooming out and you see that there's some real estate here, you might want to make the fonts bigger. And as you make the fonts bigger, you see that, oh, I need to make the size bigger too. So then we can come down here to the width, and then I can just keep playing around with the width. Okay, let me try the width of 80. And you can see this is how this look like. Nah, let me just, I like to tweak it around as well. Okay, this is 121. Okay, that looks okay. And I can even say, you know what, SpongeBob, maybe SpongeBob's font size could also be like name, and I can make it discrete. And for SpongeBob, I want him to have his font size is 23. something like this. And I think it's still maybe for the width for SpongeBob, I might make it like the name, maybe I'll make it 130 for SpongeBob, maybe prioritize him, make him have a little bit more width. Everything else stays the same. So this is what it looks like right now. Then what you're seeing is, okay, this is what this network looks like, but we have layout. And there are Y files that you can install, and I will talk about in another video. Yes, cute little Yankee's already sleeping or kind of trying to sleep. Hi, Yankee. Aww. The Yankee just sleeping off in the back. So what we can see here is that we can install those Y files. There's so many things. There's attribute, there's grid, perfuse, force directed layout. These are usually installed. And Y files are very free to install as well. So you can look at the circular layout. That can be one way to see it. Or we can also see hierarchic layout. We can see the organic layout. And you can also kind of like drag these nodes as well. So those are algorithms. These are typically just some algorithms and that are trying to make these predictions. So let's just kind of stick with the hierarchic layout, grandma, grandpa, Margaret, SpongeBob, and then we can try to see if we want to kind of drag this here, have SpongeBob here. We can see that this is what this network looks like. It's a little bit messy, but we can kind of see, okay, there's some hierarchy. We can do some removing of overlaps as well. And if we click the remove overlaps, it looks something like this. Now, what we can also see is that, okay, we have these edges going to and from each other here. So what it turned out is that I had this network from before. Apparently, I did not save it properly. So now I'm just going to get rid of this here, and I'm going to get rid of one of these edges. I had kept that by accident. So now what I was showing was this network. So if I want to make some changes, I can just cut this because I had accidentally put this here. I can just do edit and then cut. So I just deleted that from the network because again, I had accidentally put in the opposite thing, grandma to grandpa, and I didn't want that. I just wanted it to be just one edge for each, one edge between these two. So if you make extra edges, you can just cut them as well. So I just deleted those edges. And then for the style, we walked through the style, how we can expand all of these out here, label font size, transparency as well. I want this to be like 30, which would be so transparent, but no, I don't want it to be so transparent. Maybe I'll make it 149. It looks the transparency, where the higher the value, the less transparent it will be. Then for the edges, what I could do here, and again, every time I change it, I can do like Y files, remove overlaps as well. And I want to make it so that, our line types could be such that maybe I want it to be like more double lines if you're married. So I want it to be the relationship, maybe is how I want to define these edges. So for when I'm looking at the edge column, in the edge section here, I'm kind of looking at the edge table. When I'm looking at the nodes, I can look at the node table and see what I have. So for the edges, edge part here, I'm clicking here and I look at relationship, and maybe I want to kind of have a different one that is based on there's no weights here. There's no weight on the edges. It's not like, this is like number of years that they've been married or something. It's not like that. So father to child, mother to child. Maybe the default I want to have is just this dash parts for everything. But if you're married, I kind of want it to be like parallel lines. So these two are married. So that's how I can show this edge type over here. Then what I can also do is this source arrow shape to target arrow shape. So this is something I usually get tripped up on. So the source arrow shape, okay, so in this situation, let's focus on SpongeBob. So in this situation, SpongeBob is the target, and I'll just put S for source and T for target for Harold to SpongeBob. And then we can see that the father, the source arrow shape is focused on what will be the shape right here. What will be the shape right there? That's what the source arrow shape is saying. So let's say I want there to be some kind of a shape, but maybe there's a delta short. Then you see that this is the source. So it's source to target. It goes source to target. So that's what that would be here. Like, but that's not the way that the direction goes. So I'm just going to go back with none. None. So that's what I have here. That so I choose none for it. But for the target arrow shape, then that one is going to be that's what it will be. So what I could say is that for the target arrow shape, I think that we should have a target arrow shape for based on the relationship. Like if you're a father to child, then I think that it can also be the same thing. I like to use open delta. And if you are a mother to child, you can see how the mother to child has to be done too. I can make it as an open delta as well. And we see that there's nothing on these edges for marriage. So that's how I can do that. And then the other thing I can look at is labels. So maybe I want to label on these edges as well. Maybe I want to have the relationship name here and then have it as a discrete mapping. So father to child, I can call it like parent. Ah, married is married. Parent. Ah. And then I can also have the label color. Like maybe I want to have like a blue here, and maybe I want the font size to be like 15. So you can see this over here that, there's this relationship. I can also just move this up a bit if I want to move this down. Maybe have them line up like this. And then like, so I can also just see, okay, well, this looks kind of nice. This is just, again, and I can save it, SumDrive demo version 2. So anytime I need to load it up, I can just load this network up. So Yangshi, we have finished making our network. Oh, but you were sleeping. We finished making this network. So now we're going to export this network, Yangshi. To export it, we can export this as a network. We can export it as an image. And then I can say, okay, PNG, or sometimes I like to have it as a PDF as well. And whatever is kind of in this area will be printed out. So maybe I want to have it more zoomed in like this. So I'm going to just do export as image, change it to a PDF, and then just do, maybe I want to do it like as a landscape. So have it going across this way. So portrait is going to be this, it's longer, but landscape is wider. Okay, so that's what I'm going to do. And I'm going to do, okay, hide labels means that there's no labels on this and you're just wanting to get the network just for the sake of it. So now I have created this. And I'm going to go here to the Cytoscape demo, and I've saved the file there in that folder. So I'm just going to go here and click this. And then what you see when I open it is that we have this network here. We have Sherm, Old Blue, Harold, Margaret, SpongeBob, Grandma, Grandpa, and the relationships. So there you have it. This is just a very introductory guide to working with Cytoscape. And you can see here that I can keep on again, changing this view. Very interesting views out there. It kind of looks like a circuit board. You can just do Command Z. I Control Z to undo it. Like I can do edit, undo. Then a pan is just moving in, radial layout. This also looks like a flower. There's so many interesting designs out there that you can look at. Organic edge router. But something about this was a hierarchy, like, the grandparents, parents, kids, there's a hierarchy. And that's kind of important, especially in the cat kingdom. Yang, she likes to be the big guy. He's like flexing. He likes to flex a lot. So there's always hierarchy. So I thought of using a hierarchy. But there's so many things out there, that you can try out for these networks. So I can just try out so many different things and then just try these all out. There's also tree layout. Then of course I can always just like stretch this, stretch that, and so on. So many things. That was like a traffic light. So this is an introductory guide to kind of getting started with Cytoscape as well. And I had made one edge going in this direction and that direction, and I just forgot, that to save it when I loaded it in. So I just showed you how you can delete two edges as well. And this is just this little network here, and we did our best to try to represent that network in this format. I mean, of course, it's not as cute as this network is over here, but in its way, it's trying to still show us some of those details. It's trying to still show us. Oh, 1 second. Something like this. Married, Sherm, Old Blue, Harold, Margaret, Stanley, Todd, and Blackjack. And we could have also done something where we, colored based on the genders or anything like that. We can always tweak up the networks. So this is just, guys, an introduction to network visualization using Cytoscape. There are other tools out there. There's Plotly, there is iGraph, and so on. So please do check those out. And please stick around for my other tutorials on working with Cytoscape. We're making very complicated hairballs, Yankee. So I'm Saniya. This is cute little Yankee. And if you found it helpful, please like, please subscribe, and please share this video with others. And please let us know any questions and suggestions that you have. Thank you, guys, and have a beautiful time visualizing some networks and getting started. And again, Cytoscape is this free tool.